Hi class, today we're going to deal with solving linear inequalities. Now we've been solving equations and you'll notice that when we take a look at the steps for solving linear inequalities that the very first step tells us to solve in the same exact manner that we've been solving our equations. Except there's one thing to keep in mind. You want to, if you multiply or divide by a negative number, reverse your inequality. And that's very, very important. When you multiply by a negative, it's saying to take the opposite. And the opposite of a less than symbol would be a greater than symbol. Notice that they're just the reverse of each other. And the opposite of a less than or equal would be a greater than or equal. And notice that they're the reverse of each other. So when we solve our inequalities, we're going to do them in the same exact manner that we've been solving our regular equations. Except if we multiply or divide by a negative, we have to take the opposite of our inequality, just like we would be taking the opposite of a number. So let's go ahead and take a look at a problem and do this step number 1. Let's say we have 2x minus 7 less than negative, or actually let's do positive 5x plus 3. Now, when we do this problem, the first thing we want to check out is see if everything is simplified on both sides. And if you look at the left-hand side, this is simplified, and the right-hand side is also. So then we need to move our variables to the same side. And we have variables on both sides. When we're doing inequalities, I particularly prefer to have them on the left, and you'll see why at the very end. So I would, rather than leaving my x's positive and moving them over here, I'm going to actually move this 5x to the other side, and so that all the x's are on the left-hand side. So I'm going to do that by adding the opposite, which is a negative 5x, to both sides of the inequality. That addition property of equality allows you to do this, and it still applies in a different form when you're doing these. These cancel, and you have a 3 left here. And on this side here, when we combine those, we get negative 3x. And now I need to go ahead and move anything added or subtracted to our variable. And I have a negative 7 here. The opposite of that is to add 7. So I'm going to add 7 to both sides in order to move these 7 over. These 7's cancel, and I have negative 3x less than 10. Now I need to move my negative 3 here, and it's being multiplied, so the opposite would be to divide both sides by the negative 3. But notice we're dividing by a negative 3. So what's going to happen is this symbol is going to flip over and reverse itself at this point. And what we're left with is x greater than negative 10 thirds, instead of x being less than, because we had to reverse our symbol, and these 3's canceled each other out to make a positive 1x. Now, I have what looks like a solution, but notice that this was only step number 1 here. When you have inequalities, another difference between them and equations is how you write your solution and what you do with that solution. So let's take a look at step number 2 here. And step number 2 says to go ahead and graph your solution. You always take this solution that you get and you put it on a number line and graph it. So let's give ourselves some room here to make a graph, and we can talk about the notation of your graphs. Now, your graph is going to be on a number line. I'm going to put 2 of them here because there's 2 different ways you'll see things graphed, and I want you to recognize both of them. So here's a number line, and here's a number line. What you need to do is on each of the number lines, you want to locate negative 10 thirds, and here's 0. Negative 10/3 is negative 3 1/3. So if we go this way, we would label negative 1, negative 2, negative 3, negative 4. And negative 10/3 would be right in the middle here. I'm going to label that as negative 10/3. And we'll do the same thing on the other number line. Now, there's two ways to graph this solution. One way is dealing with the notation we call interval notation, and then another way is a common way to see set notation. Now, there was a reason why I wanted this x on the left side. It's because when you look at this inequality now, what we're going to do is notice that this is a greater than. And when you're looking for values greater than a certain value, so this is x greater than negative 10/3, that's going to be things corresponding on the number line on the right hand side of that value, which means when we do our solution, we're going to shade this side of the number line over here for both of them. The reason why I wanted your variable on the left-hand side is because notice if you look at this inequality, when the variable's on the left-hand side, this inequality looks like an arrow. Notice it's pointing the direction that we shaded. So one thing that you'll do on your graph is shade, and if your variable's on the left-hand side, the inequality will help you determine which side you shade. If the variables on the right-hand side, that doesn't work. So keep that in mind. Now the other thing to keep in mind is what do you do right here at the value negative 10/3? Well, you have four different inequality symbols. We have less than, we have greater than, we have less than or equal to, or greater than or equal to. Now, there's two ways to denote the less than and the greater than. These two symbols mean that you get really close to that value, but you don't touch it. So we want to be bigger than it. We can be very, very slightly bigger than it, but we want to be bigger than it, and we don't want to include the number. So to signify that, we have two ways to deal with that. One way is the way that we're going to deal with in interval notation, and that's to use round brackets. The other way is to use an open dot. One of these graphs I'm going to use the round bracket, the other one I'm going to use the open dot. The top one here I'm going to use the round bracket. Now the round bracket looks like a parenthesis, and you put it right on the value, and notice that I'm curving towards the direction I'm shading. So that's one way to graph it, would be to put it on the graph exactly the way you see here. The other way would be your open dot, and that open dot at the value signifies to get really close to that number, but don't touch it. So the other way that you may see it graphed is as you see here. This way here is typically what we see when we're dealing with set notation, and this way here is typically what we see when we're dealing with interval notation. So that is what you do when it's a less than or a greater than. Now, if we had had a less than or equal to or a greater than or equal to, these two symbols here allow you to include the value because they're less than or equal to, which means you can be equal to the value you come up with, or greater than or equal to, which also means you can include that number. To signify that you can include the number, instead of a round bracket, we use a square bracket. And a square bracket will look like this. Notice how it's squared off instead of round like you see up here. That's what you would use in interval notation. In set notation, we use a solid dot. And a solid dot would be just like this open dot, except for you fill it in like that. And that's to signify that you actually include the value. So that would be the difference between having just a less than or greater than, or to have a less than or equal to or a greater than or equal to. Now, that was only step 2. There's actually 3 steps here. So let's take a look at our step 3. Our step 3 is to write the solution in interval notation. You could also write it in set notation if you're asked to, but typically the problems that we're going to be doing will be writing it in interval notation. Now, interval notation is very easy to write if you have a graph written down. And for interval notation, what you do is you start on your number line going from left to right, and you go from left to right till you find the first thing that's included in your solution, which in this case is -10/3 with a round bracket here. So the way you signify that for writing your solution is you do a round bracket and then you write the value that that round bracket is at. Then you put a comma, and after the comma, you put the last thing that's included in your solution. So if we go back to our number line and we continue on across the number line, the shaded section actually goes out towards infinity, and it's infinity on the positive side of our number line, so that would be positive infinity. So after the comma, we put the infinity symbol, which is like a sideways 8. Now, you have to think about infinity. Infinity goes on forever. So you can never actually reach infinity. So infinity will always be a round bracket. If you could actually touch infinity, we would use a square bracket, but you will never actually reach the largest number or the smallest number that exists. So it's a round bracket. So this here would be considered our interval notation for this solution that we got from our inequality. Now, this one had a greater than symbol in our answer, which was one of these here. Let's do a problem that has one of these so you can see the square bracket or solid dot being used. So we're going to go ahead and take a look at a problem that has a little bit more involved also, and it also has a less than or greater than involved in it, that less than or greater than or equal to involved in the solution. And we're going to be doing 3 times x plus 1 minus 5 less than or equal to 2x plus 4. Now, this particular problem we're going to solve in the same way we would solve our regular equalities. And if we have to multiply or divide by a negative number, we will reverse this symbol that we see right here. But in the meantime, we'll just leave it alone until we find out if we're going to end up doing that. The first thing I need to do is distribute my 3 here. So let's do that. We get 3x plus 3 minus 5 less than or equal to 2x plus 4. Notice that this right-hand side here doesn't have any simplifying that needs to be done, but we still have to combine the 3 and the -5 here. So that gives us 3x minus 2 less than or equal to 2x plus 4. Now we need to go ahead and get our variables on one side. So I'm going to move them to the left, which means this 2x needs to move over here. And the opposite of a positive 2x is a negative 2x. So we're going to add a negative 2x to both sides of our inequality. Now we're adding right now, we're not multiplying or dividing, so we don't do anything with our inequality symbol. You only do that if you are multiplying or dividing. Over here, these cancel out to make 0, so we're just left with a 4. On this other side, 3x plus negative 2x is just an x. And now notice that we need to move this negative 2. The opposite of that is a positive 2, so let's add 2 to both sides. These cancel out, and I have x less than or equal to 6. Notice we never even had to multiply or divide by anything, so we did not reverse our symbol. You only do that if you multiply or divide by a negative number. If you multiply or divide by a positive number, you leave the symbol alone. So only do that when you're multiplying or dividing by a negative number. I now have my solution. However, I have not graphed it or written it in the proper form. So let's go ahead and make a number line. And we are going to graph x less than or equal to -6. So on your number line, you're going to find 6. And then less than or equal to, notice since I have my variable on the left-hand side, this can act like an arrow and it points this direction. And less than or equal to means things smaller, and things smaller than 6 are over here. So what we're going to do is we're going to shade values on our number line that go this direction. Then when we look at our symbol here, it's a less than or equal to, which remember was a solid dot, or we use a square bracket. So let's use the square bracket, and it looks like this. If we had used a solid dot instead, our picture would look like one that at the 6 we have a solid dot, and then we shade this side here. So either picture is fine for your graph. Now let's take a look at writing our interval notation. And again, remember our interval notation, you go the direction you read across the paper, and going from this left-hand side up, the first thing that we hit is -infinity, because this shading goes on forever in this direction, so -infinity is the first thing that we hit. So when we write our interval notation, remember infinity can never be touched, so it's a round bracket. And since the infinity is on the negative side of the number line, we do -infinity like you see here. Then you do a comma, and then continuing on, the last thing that we hit in our shaded area is this 6. And this 6 is incorporated with a square bracket, so I put a 6 here and I put a square bracket next to it. And this would be your proper notation for your solution that was x less than or equal to 6. The graph would look like this, and the interval notation would look like that. And that's how you deal with your solving your inequalities. So you are ready to go tackle problems that deal with those.